Okay, we're going to start a linear functions unit, and to do that we need to do a little basic review of slope. You should have done a bunch of slope in grade 9. People remember slope in different ways. Some people think about slope as how steep a line on a graph is, and they'll often look, is it positive or negative? Is it going up? Is it going down? There's different ways people remember how to calculate slope. Some people like the idea of rise over run. Some people like this the way of delta y over delta x. Delta means change in, so change in y over change in x. Some people remember like a formula where you subtract the two y values, you subtract the two x values. They're all the same type of thing. This method here will have some advantages a little bit more later on. This, when you apply it later on in a year or two, will kick in a little more, but it's all really the same thing. Now, there's different formats that the information can be given at, and depending on the format, there's different ways to extract slopes. Right here it says, we got this y equals 5 over 3x plus 4. This is a great little thing in the way it's set up because it's in slope-intercept form. If you remember from grade 9, good old slope-intercept form is y equals mx plus b, which is the greatest thing ever because that m value is the slope. So as long as it's set up like this, it's really, really easy to find the slope. So over here, the slope would just be the 5 over 3. I mean, that's really simple. And for this one over here, don't forget the negative, the slope being negative 1/3. So it's just that easy when it's up in slope-intercept form. It's pretty nice. Just got to make sure it is in slope-intercept form where it's y all by itself is equal to something times x plus or minus possibly a number. Sometimes instead you're given a graph and to find the slope. We can these two questions here. And it's kind of nice when you have the points, makes it a little bit easier. The first thing I'm going to do is I'm going to write down the coordinates of the points because we'll need those for what we're going to do. So if I just take the coordinate of this one here, that would be point number 1. Whatever point is further to the left, that is point number 1. So here the coordinates for this one would be 0 and 3. This one's got the coordinates of 4 and negative 3. And what some people do, especially if they take the rise over the run, they'll actually take these 2 points, they sort of make a triangle out of it, and they'll see how much it goes up. So in this one, the triangle goes up by 6, that'd be a rise. It goes across 4, so that would be run. So if you like the rise over run idea, so rise over run, the rise is 6, the run was 4, which reduces to 3 over 2. But then since the line's going down, they go, hey, that's actually a negative slope, so then the slope would actually be negative 3 over 2. So that's one way to do it. If we look at more of the formula type way, which looks something like this, we can look at the values, and I'll label the values to make sure we're using the right ones. This is the first point here, so that would be x1, and this would be y1. This would be my second x, that's my second y, and those values would then substitute into this expression. So my y2 is negative 3, my y1 is 3, my x2 is 4, my x1 is 0, negative 3 take away 3 is minus 6, 4 take away 0 is 4, and you end up with negative 3 over 2, which is the exact same thing that we had over there. So it gives you the same result. I'm going to stick with this form usually because it just has some advantages for what we're going to do a little bit later on, and it comes in handy, but it doesn't really matter too much. Okay, so if I go to the second one here, again, we got some points given. My first point here, this is point number 1, this will be point number 2. Point number 1 over here, the x value is minus 5, it goes down 4, so we got negative 5, 4 for the coordinates. This one's got negative 2 and 3 for coordinates. So if I do my y2 minus y1, x2 minus x1, and yes, writing this out actually is a good habit to get into, to find mistakes and errors if they happen and see how things sort of piece together. So if I substitute this in here, my y2 is 3, my y1 is, oops, I have 4, should be negative 4, minus 4. And for my x coordinate, my second x coordinate is minus 2, and my first x-coordinate is -5. You gotta be careful with negatives, not to lose them. So that's why brackets around the negatives is kind of handy. And if we repeat this together, 3 take away -4 would be 7, and -2, that will become a plus, so sort of like -2 plus 5 would give me 3. So I have a slope of 7/3. And if you like the rise over run idea, from here to here, the rise would be 7 spots, and the run is 3 spots, so it still works out. So we get a slope of 7/3. And it's often really common to leave slopes as improper fractions because you can actually see the rise and the run more easily than if it's a mixed fraction. Okay, so similar, we got these guys here, except these guys don't have dots given to you, so you have to sort of pick them. It can be really challenging sometimes to know if a line is exactly in a coordinates, and sometimes it's sort of like a best guess idea. But this one right here looks pretty good. And I'm going to use this one over here, also looks pretty good over there. And I can use my slopes in order to figure this out. So this time I'll actually do the delta y over delta x type notation, which is pretty much the exact same thing as the rise over run. If we look at my change in y, it's going up 3, then another 4. My change in y was 7. And my run, or my change in x, got 2 here, another 2 there is 4. So my slope would be 7/4. Okay, so that's that one right there. It's positive, it's going up, that's totally fine. Okay, for the next one, I got to pick a couple points. That guy actually right there, that looks pretty good right there. I'm trying to find these good intersections. This one looks pretty good here as well. And if I did my change in y over change in x notation, first of all, I don't even know necessarily what the coordinates are, but since it's going down, I know it's negative. I'm just going to go throw a negative right in front right away because I know it's a negative slope. And then I could look at my change in y. Let's say there's 2 here, there's another 4 there, so that's 6. And horizontally, I'm going 1, 2, 3, 4, 5, 6, 7, 8. So -6/8, which reduced to -3/4. And it doesn't really matter which 2 points you pick on the line. You should end up with the same slope no matter what. I'm just trying to pick points where it looks like it's actually going through a little intersection type thing. Okay. All right. So last thing is when you just have pairs of points. And this is where the formula type thing really kicks in nicely. It is a good idea to label the actual points themselves. For example, calling this, x1, that's y1, this would be x2, y2, just to keep yourself from making any possible errors or anything like that. And I'm just going to do that all the way across and get it all out of the way. And then I don't have to worry about doing it later. Okay. So here, the slope, this is where the y2 minus y1, x2 minus x1 notation comes in nicely. So my y2 is a -7, and I'm going to subtract y1, which is 9. I've got an x2, which is 2. I'm going to minus 0. So -7 take away 9. Of course, is -16. 2 take away 0 is 2. So that gives me -8 as a slope for that one. Okay, so same idea here. I would have 20 minus a -11 over a -14 take away a -13. 20 take away -11, that becomes a plus basically, so that's 31. And -14 take away -13, so basically adding 13, so that's -1, which ends up being just -31 for a slope for that one. Okay, so I do the third one over here. Y2 minus y1, well my y2 is, I've got 13 take away -2 over -19 take away a -17. So 13 take away -2, that would be 15. -19 take away -17 would be -2. And you could just reshift things a little bit here. A lot of people like to just put the negatives out in front if you want, or put the negative in the numerator, but negative 15 over 2 should work for that one. And the last one over here, I've got 20 minus 20, and I've got negative 19 take away 6. And with this one, with that 20 take away 20, I know that's a 0 up on top. That's going to give me negative 25 in the bottom. I know this is going to be 0. And 0 slope, of course, means that it would be a perfectly flat line. If it's vertical, it's undefined, and you can't really do anything with it. But with a 0 slope, that means it's nice and flat. So again, these are just different ways to find slope. Different strategies come up in different scenarios and circumstances. Most of this should generally be reviewish for you guys from grade 9 math. But again, people have come from different backgrounds. Some people have done more than others. So it's good to have a little review and refresh on how to find some of the find slopes in different circumstances based on what kind of information that you are given.